So here, when I say we're looking at exponentials, just FYI, just in case you didn't realise that, we are looking at exponentials. Hopefully that's got right too. We're having a strange things wrong today. Exponentials. If I ask you to plot, what am I asking you to do? Draw a table. Okay, so here for x, y, when y is equal to 5 to the power of x. When x equals 0, what is 5 to the power of x? 1. Good. When x is 1, 5 to the power of 1 is 5. When x is 2, that's 25. And that's just going to get bigger and bigger and bigger, eh? I'm not going to plot 225, am I? Okay, so what would x be? Sorry, if x is negative 1, what would y be? 1/5. Okay, 1/5. Now, if I was to plot those points here, 0, 1, 2, 4, 1, 5, 1/5. That's my graph already. If x was negative 2, what would y be? 1/25. And so that's going to be ridiculously small there, right? What's this graph going to approach? It's going to be another asymptote, eh? So we've got another asymptote here on this x-axis. Yeah? Okay, so we can't actually draw a line that, let's see how fit this is. A line that deviates or touches this asymptote. So it can't deviate away from that asymptote, and it can't touch it. So my graph basically looks like that there. That's all my graph can look like. Yep. If I draw the next one, if I plot the next one, I'll plot these values here. When x is 0, y is, when x is 1, y is, x is 2, x is negative 1, 1/3, negative 2, 1/9. Do you see a pattern there? Yep. No, the x to the negative 2 one is 1 over x to the 2 one. X to the negative 1 is 1 over x to the 1. Right. Anyway, plot these points. Goes through there, there, there. So it's basically looking like that one there. Happy with that? Does that seem pretty straightforward for those basic exponentials? So here are the graphs of y equals 3 to the power of x and y equals 5 to the power of x. What do you notice about those two graphs? Both go through 1. Okay, why will they all go through 1 if they're not offset? If they're not all translated? Because anything to the power of 0 is 1. Cool. What other key features of this graph do you think there are? If I put in this value, if I put in this graph here, what do you notice about this graph and where it intersects? And where it intersects those graphs? Intersects at 2, 3, 4, and 5. It intersects at 2, 3, 4, and 5. What do you notice? It intersects at that base. Yeah? So go back to here. What are the key features of my exponential graphs? Key features will be it goes through 0, 1, it goes through 1 and whatever that base is there. So this is my base, so that is my base there. We'll have an asymptote at y equals 0, so in other words at x-axis. And your graph, it might be quite small based on the shape. Okay, just like I drew over there. Are there any questions with those key features? Seem pretty straightforward. Okay, so just like with hyperbolas, just like with parabolas, what are we going to do now? translate them, yeah? So how might you translate these exponentials? What are the key features that you think will translate? So you think we might be able to say y equals so a into x minus h. Okay, h, I put h for a reason. What does that x minus h do? Shifts it horizontally. Yep. So this one here will shift it horizontally. Okay, but what's it shift horizontally though? How can you shift it horizontal asymptote horizontally? There is no vertical asymptote. Yeah, it'll move these points here. Those points will now be shifted across that many places. Okay? Happy with that? What will this part here do to my graph?
Shift the horizontal asymptote.
Yeah, that will shift the horizontal asymptote up and down. Okay, but it'll also shift these up and down as well, eh? But the key thing is it'll shift that there up or down. Does that make sense? Happy with that? Okay, so how about having a quick sketch of those? I'll push pause again. Have you guys a crack at sketching those graphs? Okay, note that the words I'm using, sketch those graphs. So not plot them now, not using a table. Sketch those graphs. Okay, sketch them. Okay, so if I asked you to sketch this one, how would you do it? I would start by just drawing in my standard one, or drawing the points of my standard one. My standard one being y equals 4 to the power of x. You happy with that? If I draw that standard point, just like drawing the standard parabola, just drawing the standard hyperbola, what now moves? Those 2 points. Which 2 points? Where do they go? To the left. How many places? 1, 2, 1, 2. Here's now my graph. Okay? You happy with that?
Yep.
Okay, next one. Take this. So the next one, I would be doing the same thing. Where's my standard graph? It's just here and here. Wait, watching please, pay attention. What does that plus 1 do? Moves everything up 1. So now it's there and there. So my graph's like that, is it? No. Because what moves? The asymptote. And I need to make sure I move my asymptote. Okay, so my asymptote is now along there. In a nice rainbow colour for everyone. Well, yeah, that's a poor graph. But here's my graph like that. Happy with that? So now, wait, thank you. If I show you now, here's what they look like. So here is me starting. So that's my starting point. In the bracket, if I now add that number, it's going to move to the left. Yeah. It looks like the shape is changing, eh? Actually, it looks like the shape is changing here, eh? But you're just seeing a different fraction of the shape. Okay. So the shape is exactly the same. You're just seeing a different part of it. So x, what was x plus 2? Was it? So that's what my graph should look like. Okay. Happy with that? Here's the next one. What does that plus v do? That plus v will just move my graph up or down. Okay. Again, it looks like the shape is changing, but the shape is not changing. It looks like the shape's changing quite a lot there, but it's not. It's just the shape of the thing. So it was x plus 1, wasn't it?
Yeah.
I'm going to be struggling to change that to be fair to me. Okay, so you can see there, my new asymptote should be along near an x, or at y equals 1. Any questions with that stuff? All right. Thank you, sir.